I'm Carmen Iannacone. I'm the CTO here at the Smithsonian. I was asked by my friend Gunter to chair this lightning round session because I can be rude on demand. And if you haven't been to a lightning round session, that may in fact come into play. What we'll do is we'll divide the time that we have, and that's roughly 30 minutes among the 8 speakers. And they'll come up, do a brief presentation. For the next 30-ish minutes, my phone will be the one that matters in terms of making noise. And at the 4-minute mark for each presenter, they're kindly asked to allow their neighbor their time. And if we have to get tough, we will. The first up, from the Smithsonian's Office of Exhibit Central, Carolyn Thome.
Hello. This will be very funny because I am unprepared and just walked over here. So I work at the Office of Exhibit Central, and this is where Vince and Adam were born. And this is where this whole event was born, so they started it there. What we do is we prepare some exhibits for the institution, not all of them. We do fabrication, we do casework, we do graphics, we do design, we do editing, model making, and that's where I work, is in the model making department. And that's where we have incorporated, sorry, I literally ran over here. We incorporated the digitization into some of our replicating work. Normally, the old school way is to make models, is to make molds. Now we can capture things digitally instead of harming artifacts, which is not what we try to do, but if you make a mold of an artifact, you will inadvertently, you're changing it a little bit. So it's a great tool and technique for us to have. And we also have 2 3D printers that are print in full color. We also have CNC milling machines, CNC routers, where we can use a lot of this digital data to create replicas. And it's a lot of fun to work there, and we get exposed to everybody here, which is great. So we get out and get to meet different curators and different aspects of the Smithsonian. So it's a great place to work, and I wish we could hire you, all of you, but we can't. That's all I have to say, so sorry. Thank you.
Thank you, Carolyn. If you get a chance to visit OEC or sneak in the back door, I recommend it. John Weaver.
Just wait a second on the video, okay? Just one second. So I was not told it was 4 minutes. I was told it was 1 minute. So this is not a lightning round. This is a greased lightning round, right? Okay. So you can start the video now. I'm John Weaver from Abilene Christian University. I'm the Dean of the ACU Library and the Maker Lab, where we focus on 3D printing. This story begins in the art studio of Jack Maxwell, an art professor at ACU. For 8 years, he designed and built 3-dimensional models of a sculpture, Jacob's Dream. The 34-foot-high statue portrays the Old Testament story of Jacob's Dream. It stands near the front of the university, completed in 2006. And in 2012, Jack's students asked how they could preserve and provide greater access to the sculpture. We partnered with Capture Dimensions in Richardson, Texas, and they capture subjects for conversion to realistic full-color 3D models. They have an array of 80 cameras which they fire simultaneously using a custom hardware solution, and they stitch the photos together into a 3D model through the process of photogrammetry. And so that we were able to preserve and reproduce Jacob's Dream in a 3-dimensional form. Now, the 3D tools impact Jack Maxwell's future work, and he models the sculptures more efficiently, focusing on meaning and composition. And Jack tells us that the entire sculptural field is about to be transformed completely. If you'd like to know more about this collaboration between Abilene Christian University and Capture Dimensions, you can go to the booth in the Tech Hall, or you can go to our URL for the Maker Lab at ACU. Thanks.
Next up from the Digital Commons, Nick Karelchuk.
Hello. I'm actually James Kite. I'm a library associate at the Digital Commons. The Digital Commons at the Martin Luther King Jr. Memorial Library provides a gateway for the general public to explore the exciting world of 3D printing, 3D scanning, and associated technologies. The Digital Commons is really the latest endeavor in the library's effort to encourage digital literacy and technological literacy in the community. It's also an effort to bridge the digital divide by creating access to these technologies for people who might not otherwise encounter them in their lives. Right now, we feature 2 3D printers, which we use for our 3D printing service, as well as a 3D scanner. And we are looking forward to expanding our capabilities in the near future. In addition to the actual equipment, we provide education and support. We have a great, friendly staff of people who are more than willing to help patrons on 3D printing projects, but we also offer a series of classes. We have an introduction into 3D printing that is geared towards novices, people who have never encountered a 3D printer before, that explains the technology, how it works, and its applications. We also have an introduction to 3D modeling class. It looks at some CAD programs, and also a 3D scanning course as well. We are looking forward to, in the near future, partnering with businesses and nonprofit organizations to do showcases for the community on what's happening in the field. And really, the goal is to continue what's always been a big part of the library's mission, which is to share the information, the knowledge, and the skills that people need to be participants in our society and to explore what's happening out there in the world. Thank you.
Thank you, James. From the National Capital Area Medical Simulation Center, Eric Acosta.
Alrighty, as I said, my name's Eric. My coworker Valerie's here with me. And what we're doing is we're talking about some of the medical simulation technology that is being developed at the National Capital Area Medical Simulation Center. And we're showcasing 2 of the things that we're developing. The top that you see here is this is where we can create a virtual patient, and you can use haptic devices. So not only can you see your virtual patient, but you can actually use the devices to go through and do things such as use a virtual scalpel to go through, make an incision in the patient's neck, go through, and each of the step. We can run it in mentor mode so you kind of learn step by step. And we have also a kind of a test mode that you can go through. If you make enough mistakes, you can actually take your virtual patient's life. Good thing about them, we just reset them, bring them back to life, and we promise no virtual lawsuits. So we also are working on a head trauma simulator, so you can go through and learn how to go through and open up the skull, so you can go through and decompress whether there's blood that's going in there or there's tissue swelling. And so this is all for surgical training. The bottom is kind of our big baby that we're creating. It's an immersive training theater that we're creating. So the whole idea is that if you're training, and in our case we're doing medical simulation training, is that we want to be able to recreate the environment that you're training for. So can we go through and create the different environments, whether you're down in the Middle East, taking a helicopter ride, or going through into a hospital. Using the virtual reality, we can create the 3D graphics, integrate surround sound, and also have other distractions, whether it be really pleasant or unpleasant smells. You can go through, if there's an explosion that happens, we can go through and rain debris, do smoke. We can also have heaters in there that we can go through and make you really uncomfortable. So you can see by the layout of the system that it's a 2-pod configuration. And with that, what we can do is that we can carry out a part of the scenario in one pod, go through, transition to another one. So by going back and forth, it's almost like a large play, or what we like to call is the world's largest video game that we can play around with and use for training. And so you can kind of get a feel for the dimensions here on the right-hand side. This is where they're going and transitioning from a urban environment to do medevacs. So here next month, we actually get our motion platform in, so we actually be able to put people into a helicopter and go through for a nice ride. So that system sits in about an 8,000 square foot room, a little bit too big for us to bring with it. But if you want to come by, see some of the videos, see some of the behind scenes, how some of the environments are generated, or go through and play with our simulator, please come by and take a look. Thank you.
Thank you, Eric. From the Smithsonian Gardens and Swedish ICT Interactive, Tom Rydell or David Hughes, or both?
You have a slide for me? Okay, so we're from Sweden. I'm from England. I'm not Swedish, but we're bringing to the conference here a system called Inside Explorer. So that's a little bit different from what's been talked about before. And this allows museum visitors and science center visitors to explore not just the surface, but what goes on inside the body or inside the artifact that's been scanned. So we use, in the collection side, we're actually mixing CT scanning, both with medical CT and micro CT. So we end up with actually a volume of information actually inside the body or inside the artifact itself. But we're combining that also with photogrammetry and laser scanning. And that's kind of a new innovation which is happening here at this conference. Then we're finding that using this type of material, that we're actually getting some really stunning discoveries. And very often what you see on the outside, you don't know what you're going to find on the inside. So in fact, this particular example is a 5,600-year-old mummy. It's pre-dynastic, which means before what everyone normally thinks of as mummies, from the British Museum. And this particular image here I absolutely love, because this is the point when everyone discovered on the table that he had actually been murdered. So we ended up with a 6,000-year-old CSI cold case rather than just a nice visualization project. This became a really big project and is still ongoing, and we actually have this example here at the conference. So we then get involved in building projects, and we're now doing projects with Egyptian mummies, Peruvian mummies, natural history artifacts, fossils, geckos trapped in amber, meteorites, all sorts of amazing stuff. But it's what you find on the inside that's really fascinating. And also we've been working here with the Smithsonian. We have a number of artifacts that they've been kind enough to send to us, which we've actually put onto the table. So the final piece of the process is actually putting it in the gallery, and it's all about the experience. And this is where it gets really exciting to see when the general public start interacting with something which is fundamentally quite complex, but we try to make as simple as we possibly can. And we have installations all over the world, Singapore, in Glasgow, several in London, and some here in the US as well. So come and see us. Come and see what the inside of all of these digital creations look like. We're running in the Tech Gallery, and we'd love to give you a tour of some of the most amazing experiences that we've managed to collect. Thank you.
Very cool. If everyone, if you haven't gotten a chance to see the Tech Gallery, a few people have mentioned it. It's on the first floor of the Smithsonian Castle. Do go. Don't miss it. And that table is spectacular to see. From Nova Labs and Hack DC, Alberto Gaitan. Or I could speak extemporaneously on any topic that you'd like. Okay. If you like, we can switch things up, and Vince, Adam, we have dear friends from Autodesk that we'd like to introduce.
Thanks, Carmen. Thank you. Thanks, Carmen. Yeah, so we both need to be up here today to thank Tatjana Dzambazova specifically, who's part of the Autodesk team who helped put together the Explorer, and she's got a lot to display in the tech gallery, including Photo Recap, which is software that allows you to take photographs and composite into accurate 3D data. We've got 123D Make content from Autodesk as well, and that's going to be taking a 3D model and then slicing it up into many different layers, and then you can put it back together in cardboard, paper, stainless steel, what have you. Vince?
Yep. And I just wanted to, special thanks to Tanya, because the amazing 3D Explorer you saw us demo earlier essentially happened because of her. She was in the trenches making this happen, flying out from San Francisco many times with us, Adam and I with our big list of demands. And she was somehow magically making it happen. So what you see in the 3D Explorer is largely thanks to Tatjana Dzambazova. So we'd like to have her up on stage for a moment and maybe talk a little bit about her experience and about what Autodesk is doing in the tech gallery. Thank you.
Hi. I cannot tell you how happy I am when I see what we managed to do. It's kind of our baby. This software would have never looked the way it does if we didn't work directly with the Smithsonian. We did it for them, with them, because I always say it really pays off to get your hands dirty and work with the people who you actually make it for. But today when I was listening to the curators, I remember the first meeting with Keith, with the curator of the beautiful Buddha that we saw in every single color and dimension. The first meeting, Keith said, he apologized a priori that he is very illiterate digitally. And he felt so bad because he didn't know what we were talking about when we were discussing how new experiences can look like. To see him today rock the boats and really use the software and tell the story, and he's so happy. The first time we showed it on the Explorer, he said, "Oh, this is more beautiful than my actual Buddha." So this is really where we wanted to arrive, to have on one hand a tool to offer the Smithsonian collection to the entire world, to educators, to aficionados, to kids, to really blur the line between what's a game and what's learning, but also to give the curators who feel a little bit, they see all of this technology, but they don't have the right tools because no tool has been ever really designed for them. They've been struggling with tools that have been designed for engineers and architects and visual effects artists, and we wanted to make something that is really for this audience. So very proud. My experience working with these two guys, I would just say we had way too little whiskeys. We had to have more of those. But I'm so happy. I was crying when I was seeing it on stage because it really looked awesome. Thank you very much.
Thank you all, and thank you to our wonderful sponsors today to make this work possible. That's all we have for the lightning round today. Gunter, I'm going to turn it back over to you. Thank you very much.